this tutorial we are going to do the implementation of circular linked list, and in the previous tutorial we have already covered the concept of circular linked list. So the four functions that we are going to perform on our circular linked list are add to empty function, which will just add a node to an empty circular linked list. The second one is the add begin function, and this function will add a node in our linked list at the beginning of our circular linked list. The third function is add after function, and this function adds a node after a particular given node. And the last one is obviously the traverse function, which is used to traverse through the circular linked list. So we are going to write how these functions will work. So let's open the CLine IDE, and in this CLine IDE I have already created the structure node which has the data and the next pointer, and in the int main function I have already created a structure node pointer last, and I have made it null because initially the linked list will be null. And then you can see that I have not defined this function because that is what we are going to do in this tutorial. These function, you can see they just pass 2 arguments, and this function add after passes 3 arguments. So let's see that add to empty function passes the last pointer and also the data of the node. The add begin function also passes the last pointer and the data of the node that you are going to insert at the beginning of the circular linked list. And the add after function will pass the last pointer and where you want to insert the node. Like if you want to insert 6 after 3, so you are going to write it like this. And all these functions have a return type struct node pointer because they are going to return the last pointer, and finally we will just pass the last pointer to the traverse function to traverse through our whole circular linked list. So the first function that I'm going to write here is the add to empty function, and we know that the return type of this function will be struct node pointer, and the name of the function is add to empty function. And since this function is taking 2 arguments here, I'm going to write 2 arguments in these braces. One is last pointer, so I will refer it as last, and the second one is the data of the node, so I'm going to write int data here. And since this function will return the last pointer, I'm going to write the return statement last. So let's now how we to implement this add to empty function. So the first thing that we need to do is add to empty function is that we will to add. So first statement that we're going to add in the to empty function is where our linked list is. You use the function linked list, so attachment not equal to null. So if the linked list is not empty, the last pointer will also will not be equal to null. So if this is true, we are just going to return null. Sorry, we are going to return the last pointer. So I'm going to write here return last. The next thing that we need to do is to assign the data. So we will just create a temporary node. We will create a temporary node and we will assign the data to this temporary node. So this step is assigning node. And the last step is to create the links. That is that we are going to create the pointers and we will properly align them, or you can say you are going to properly assign them. So the first thing that we are going to do in creating links is, first of all, I'm just going to draw how the circular linked list will look like after adding the first node. So you can see that this is our temporary node. So if you want to create, let's suppose the data is 4. So to create the link, the first thing that you need to do is you need to point the last pointer to this temporary node. So we will just assign the next pointer of the last node as temp. So this is the first step. The second step is to assign the next pointer of the temp to point to the last. So we are going to assign the next pointer to the last pointer. So this is how we are going to create a link of this temporary node with the last pointer for our empty list. So let's do this in our CLine IDE. So the first thing that we're going to do is to write an if statement. So if last is not equal to null, so we're simply going to return last pointer because the linked list is not null. And the second thing that we want to do is we are going to assign data to a temporary node. For that we need to create a temporary node. So we will create a temporary node by the name temp, and we are going to use the malloc function, which is the memory allocation function, to assign or to allocate this temporary node in the memory. So this is how our malloc function will look like. So this is how you are going to assign the node, allocate the node. The next thing that we are going to do is to assign the data of this temp node, and the data will be the data which we are passing this data at the time of function call. So the data will be 4 in this case. So the second step is over. The third step is to create links. For creating the link, what we are going to do is, the first step is to assign the next pointer of the last as temp, and the next step is to assign the next pointer of temp to point to the last. So this is how our add to empty function will look like. There is an alternative way to create a link, and this alternative way is you can initially assign the last pointer as temp. So both of these nodes will be equal, and then you can just simply assign the next pointer of last to point to the last. and finally you're just going to return the last. So this is also an alternative way to create the link. First we will just assign that the temporary pointer is the last pointer, and we are just going to assign the next of the last pointer as last. So this is how our add to empty function will look like. So the next function that we're going to do is the add begin function, and the return type is also struct node pointer, and this is add begin function, and it is also accepting two arguments. One is the last pointer and second one is the data itself, and then we are just going to write the return statement like this. In this function also we are going to perform the three steps. The first step is to check whether the list is empty or not, and if the list is null, so I'm going to write an if statement here. So if the list is empty, that means the last pointer will be null, and if the last pointer is null, that means the linked list is empty. So what we are going to do is we are just going to pass this data to the add to empty function, and it is just going to return the last pointer. So we are going to return the result that add to empty function will perform, and we will pass the last pointer and the data to this add to empty function, and we are going to do this only if our linked list is empty. So this is our check statement. The next step is to assign the data, or particularly assign the node. So to assign the node, we are just going to create another temp variable, and we're going to use the malloc function to allocate it in the main memory. This should be struct node, and this should be in the size of function. So the next step is to assign the data of this temporary node as the data which we have passed at the time of the function call. So the last step is of course to create the links, that means to assign the pointers. So if we want to assign the links if we want to assign a node at the beginning of the list, let's see how we will have to create the links. So in the add begin function, let's suppose you have a circular linked list like this, and let's suppose this is the last node, and let's suppose this is pointing here. So let's suppose that we want to add the node here at this position. So that will be the beginning of the that will become the beginning of the circular linked list. So the first step that we're going to do is we will have to create a temporary node, which we have already done, and then we will have to make the next pointer of this temporary node point to the first node. So we want to make this next pointer point to the first node, and we know that if you want to access the first node, you will have to use the next pointer of the last node, because last next points to the first node. So the first step is to assign the next pointer to the last of next, which is the first pointer. The second step is to assign the first pointer, sorry, the last of next pointer as temp. So we will have to destroy this link and we will have to make this last, the next pointer of last, point to the temporary node. So to do that, we will have to assign the last of next as temp, and finally we will assign this temporary, we will assign the last one as the, sorry, we don't have to do anything now. This is the only two links that we will have to create, and in this way we will be able to add the first node at the beginning of this list. So let's now implement that. So to create the list, so to create the link, we are going to assign the next pointer of the temp as the first, it will point to the first node which we are accessing using the next pointer of the last. And the second step is to assign the next pointer of last point to temp. So these are the two steps that we are going to perform to create links, and this will add the node at the beginning of our linked list or the circular linked list. The next function that we're going to implement is the add after function, and this time, since it is accepting three arguments, you can see that there are three arguments, but the return type is the same, which is struct node pointer add after function. And since now it is accepting three variables, the first one is the last pointer, which has data type as struct node pointer last. And then let's suppose we want to pass the item, we are going to pass the data first, the data of the node that we want to add. So let's suppose we want to add 6 after the node 3. So we will write int data and then we will write int item. So you can see that the int data refers to the data where what we want to add, and int item refers to the place where we want to add. That is the main use of the add after function, and we will return the last pointer, the reference to the last pointer. So let's see how we can implement this add after function. So to add a particular node after some node, let's suppose this is our circular linked list, and let's suppose this is pointing to the first and this is the last pointer. So if you want to, let's suppose I want to add a node. First I will create a temporary node and I will assign it in the main memory, and let's suppose I want to add this node after this node, so I want to add it here. So to do that I will have to create links. The first step is to assign the next pointer of this node point to this node, and the second step to is to destroy this link and make it assign it to our temporary node. So after doing the check, what we are going to do is we will assign the next of the temporary node as the next of the node that is of this node, and we don't know what this node is, we only know the data of this node. So what we are going to do is we are going to make it, let's suppose we will create another pointer, or we can create another pointer here which is p, and since I want to make this next pointer of this temporary node here, I will have to pass the pointer. So this pointer is since last next points to the first node, since it is pointing to the first node, so what we are going to do is we are just going to pass it here. So I'm just going to write it last of next. So the next pointer of last will be equal to this temporary node, and if we want to access this node after where we are going to add it, we will run a while loop, and this while loop will just go like this. If p is not equal to last next, we are going to run this while loop, and inside this while loop we are going to write a check statement, and if the data of this pointer p, since we are running this pointer from the first position, and we are going to traverse it through the whole list until and unless the data of the node is equal to the item where we want to insert our node. So if this condition becomes true, then it means that we can now add the data to the item. So you can see that if the data of the node is equal to the item where we wish to add our temporary node, we can just run this line, which is the next of the pointer will point to the last of the next. So there is a mistake here. You can see that we will have to make it the next of p. So the next of the temporary pointer will point to the next of the data, the p. You can see that this is p, and since we are traversing from one node to the another, and while traversing we are also checking whether the data is equal to the item where we wish to enter the temporary node, and whenever this data will become equal to the item, we will just make the next pointer of this temp point to the we will use the p of next, which will point to the node where we want to add. So this is how we are going to perform the link step, and the next step is to just make the next pointer of the node. So let's suppose we want to add temporary node after this one. We want to add temporary node after this node. So now the pointer p will come to here. So the next of the p pointer should point to the temporary node. So we will add this line also, and finally we will return the last. So let's now implement in the CLine IDE, and while implementing I will again explain the concept that we are using. The first step is very simple. We are just going to write the check statement. So if last is equals to null, we are just going to return last. And now we are going to create a temporary node, and since we are also going to use the p pointer which will traverse through the linked list, so that we can add it at a specific location. For that we will use the p pointer, and it should be like this. So the next step is to allocate this temporary pointer. Before allocating this temporary pointer, we are going to assign p as the first point. So we will assign the pointer p to point to the first node, and now we will create a while loop. And this while loop will run from the first position, and it will traverse through to the last until and unless the value of the pointer p will become equal to the first node. So this is our while loop, and in the while loop we are going to write a check statement, and the check statement says that if at any position the data of the pointer p becomes equal to the item where you wish to add the node, only then you are going to allocate the temporary node. So we are going to allocate the temporary node using the malloc function. So it is struct node pointer malloc size of struct node. The next step is to create the links, and before that we will also have to assign the data to the temporary node. So main reason why we are using this if statement is because we are checking if the data of the pointer is equal to the item, because we want to add, we are using the add after function. We wish to add the temporary node after a particular node, and for that we will have to search that node in our whole linked list. So we will have to traverse and check. So we will write here traverse and also check whether it is the item where we want to add or not. And once the check will evaluate to true, we will assign or we will allocate the temporary node, and then only we will create the links. Create links. And the first step in creating the link is to assign the next pointer of our temporary node point to the node that we have searched. So we know that the next of the p node is the node where we after which we want to insert our temporary node. So p next will point to the next element of that node, which you can see here. let's suppose this is the node where we wish to enter our temporary node. So p next will be this node, and we want the next pointer of our temporary node point to this node. So that's the reason why we are assigning the next pointer of temporary node as p of next. So we are going to do the next step, and the next step is to assign the next pointer of p point to our temporary node, which is this step. You can see here that we will have to destroy this link, and this link is p next. So this link is p next, and to destroy that link we will just assign the next pointer of the p node point to the temporary node, and this is how we will add the node after a particular node. So p just means a particular node, and to reach that particular node we will first have to traverse. And the next important thing that you should remember is to assign this check statement. You will have to check whether the item of the node is equal to the particular node, and this should be double equal signs because we are checking. And the next step is to allocate the temporary node, and then to assign the data to this temporary node. The last step is to create the link. To create the link, first we will assign the next pointer of the temporary node to the next of the particular node, and finally we are just going to assign the next pointer of p as it will point to the temporary node, which you can see here. And we have seen this theoretically, or you can say just diagrammatically here, how we are destroying the links and how we are assigning the next pointer to point to the temporary node, and the next pointer of the temporary node point to the next structure. So this is how we are going to write the add after function. You will have to remember this traversal and the check statement. The next and the final function is the traverse function. So we are going to write the traverse function here, and since the traverse function is not returning anything, it is just displaying the data, we are making it as void, and it is accepting the last node, so we are going to write it as struct node pointer last. And in this function, first we will have to check whether our list is empty or not. So if the list is empty, we will just display that the list is empty. So if the last pointer is null, that means that our circular linked list is empty. So we will just display that the list is empty. And if the list is empty, we are just going to return out of this function. So let's now traverse through the linked list, through the circular linked list, and to traverse we will have to create a p pointer. We will have to create a p pointer, and this p pointer should point to the first node of our linked list, because then only we can traverse. So we know that if we want to access the first node, we're just going to use last next. We're going to use the next pointer of the last, and you can see that these two lines will make the p pointer point to the first node. We have also done this here also, you can see that. And now we are just going to use a while a while condition while p is not equal to last of next. So we will run this while loop until and unless the pointer is pointing to the first node, and then we are going to print out the data of the p pointer of the particular node. So this while loop will traverse through the whole linked list and it will display the data of that linked list. And after every traversal, or you can say every iteration, we will have to make p point to the next node. So we will have to make p equals p next, because that's how we are traversing through our linked list. So after doing this, what you need to do is this whole thing will just create a circular linked list and it will make it, and we will perform these functions, and finally we are just traversing through our circular linked list and it will display our circular linked list. So thanks for watching.